Hello everyone, welcome again in this channel. This is the second time of our assignment, and for this time I'm going to present the water treatment sheet monitoring and control system with SCADA. As we know, SCADA is a supervisory control and data acquisition which will help us to remote control our plants in the industry. Yeah, fine. For this question, it's a full project actually. The objective of this project is to design and implement a comprehensive monitoring and control system for a remote station or site integrating SCADA. Technology with a control system, automation technique, and communication technologies. So then we develop an architecture that enables remote monitoring, data acquisition, control, and visualization, addressing this challenge of limited infrastructure, human resources, and connectivity in remote areas. Yeah, let me go quickly this question. I'll put it in the description so it can be more understandable while watching the video. Yeah, for the system architecture, we will be having the control center, the remote terminal RTU, the SCADA software, the communication infrastructure, data storage and analysis, user interface, hardware and software. Yeah, this is actually the summary of what we are going to design now, and it's an academic assignment which will be done in group. By my name, I'm Benoit, the first one, and I'm going to present this assignment. Let's go in deep now. Okay, for the project name is a fuel treatment sheet monitoring and control system with SCADA integration. By going through first by the architecture, to describe it by using its architecture, we see that the control center is seen here. The control center will be a centralized location or housing the SCADA server and the operator's workstation for monitoring and control. Yeah, for the RTU, we deploy in the remote area the interface with sensors and the actuators, collect data and communicate with the SCADA server. The SCADA software, yeah, it's a software platform which will just help us to visualize, which will just help us to access the data which will be recorded in the database. And the communication infrastructure enable the transmission. Yeah, it should be just a part for the transmission. As I said, the SCADA working principle is almost with IoT. Yeah, for the data storage and analysis, there will be the storage, where to collect our data, where how to make a report, and other things, and even the decision making. User interface will be having the human machine interface, which will be the operator. Actually, a graphical user interface where a user will be there to monitor or every process of our plant. And hardware and software, those are material which will help us to perform this project actually. Yeah, let's go now for deep in the architecture. As I said, in the control center, we'll be having the SCADA server, operator workstation, data storage and analysis. That is in the remote terminal RTU. The remote terminal RTU, yeah, it's actually a module having like a gateway, yeah, which will be having help us to deploy our system to the internet. SCADA software, yeah, the software will help for the data acquisition. HMI functionalities. HMI is a human machine interface. Alarming system, yeah, those will be having those alarm system. The alarm system may be the LEDs in the graphics, which will be notifying if there is any change. And then also the trading module and the reporting function, where we can see the reports of the function, the way of the plant will function, maybe for the week, per day, it will depend. And there is a communication infrastructure. The communication infrastructure, which will be the mode by which we are going to use to communicate with our plant and the remote site. Yeah, we'll be using the radio frequency. Then the next one, and the architecture will be the data storage and analysis. Yeah, data storage and system, it will be holding data storage system analysis tool. Yeah, those will be the tool which will help us to analyze the data from our sensor. The sensor will be sensing the plants, the water treatment plants, and give us the data. Then get the information. First, we're going to analyze those data, and also to store where the place where to store data. Mainly, store a backup where to store our data. Then the data storage analysis part in the architecture will be help us to perform the task, to get the result, to get the information from the data we'll be recording. And the user interface, the next is the user interface, SCADA HMI. Yeah, actually, it will be help the user to monitor alarm display and control function. Yeah, that is the HMI. The HMI function will be helper for monitoring interface, alarm display to display those notifications and so on, and the control function. Sensors and actuators. Yeah, sensors and actuators, we all know that a sensor is a device which take a physical to it translates it to electrical signals, and the actuator will be making the contrary to taking the electrical signal and then it make it to the physical. Yeah. Then for the sensor, will be having the pH sensor, oxidation reduction potential sensor, turbidity sensor, dissolved oxygen sensor. Yeah. For the actuators, the main one will be having a valve to open and close just our plant. Okay, now I go for how it will be working. So in our field, we'll be having those instruments first. The sensor, as I said, will be having pH sensor, oxidation sensor, turbidity sensor, and oxygen dissolved sensors. Okay, from the sensors, we'll take after sensor take the data, it will transmit it to the RTU. RTU is a remote terminal unit, actually. Then from the remote terminal unit, we'll be having the field communication link. Then our RTU will be acting like a gateway. It will be taking the information from the sensors, from the PLC, and then it make it to be able to be transmitting radio signal, a radio frequency. Yeah, it translates the electrical signal to the radio signal. That's why we can transfer it from the field communication. I'll be using the radio frequency. There is a control seat communication. Yeah, those why we'll be having the control seat communication, a part of security to secure our link of communication, to secure our channel, and so on. And then from the modem, convert radio signal to the internet, so we can see it. Yeah. Then we'll be having a switch to transfer data to other device in the network. Actually, the switch in the network system will just help us to distribute, to connect different devices together to the internet. Then MTU, master terminal unit. Yeah, the command to the RTU gather the data, store data, process it, and display the information. Yeah, this is the part where we'll be now dividing those information. One will be from the panel HMI, from display the current status, engineering station with SCADA softwares, server historians, log data to analyze and predict futures. Yeah, this is a way our plants will be working from sensors to HMI, and there will be a big difference. A good part of this system, like a system can be, for example, in USA, but the headquarters is now here in Africa, for example, and now it will help us to control our plant, to having our plant, the status of our plant which in USA we're going to monitor it, even to troubleshoot it from Africa to USA, for example. Yeah, we continue. Now I go for the description. Yeah, about the description, we'll be having the central control. It will be almost the SCADA server, and we're talking about something SCADA server. Man, we'll be having the operators workstation where engineers are there to monitor and to troubleshoot, where we store our data. Then we'll be having the RTU. RTU is a remote terminal unit which will be help us to remote the PLC's information, to remotely get access to the PLC. Then we'll be having the SCADA program. Yeah, actually the software for data acquisition. The SCADA program, we have to install it, and then it will help us to access the information. Yeah, actually, from the SCADA program, we'll connect to the RTU. The RTU will be taking the information from the PLC. RTU will be connected to the central control, and so on. The information which will be at the RTU, automatically with our program we can access them easily. Then the infrastructure for communication, those are data will be transferring data between the control center and the distant RTU. Yeah. As here we can have multiple plants. One can be in Kenya, one can be another one in Burundi, Uganda, and then the central will be here in Rwanda. So to control them, we are going to make those design infrastructure to which will be take to linking those plants. Then from infrastructure, when we are talking for the way of communication, we'll be taking from the center of control and the way they are interconnected with those different plants and different locations actually. And data analysis and storage. While to talking about our subject, which is the control of water plants. So the data which will be taken by our sensors, we have first to store them and then to analyze. By analyzing, we get also the information so we can make so this decision can follow. So data analysis and storage will be ability to return gather data information, to analyze and provide historical reports of the information. Interface user. Here in the interface user in industry will be a human machine interface. Yeah, almost a graphical user interface, just a place where a screen where user will be able to monitor or process from different plants, from different actuators and sensors in the plants. Then sensor and hardware. Yeah, RTU is having the ability to interface with sensors and actuator places, fields, treatments, location. For example, the hardware, those hardware components. Yeah, those hardware components will be having the part of sensors and actuator. Sensor will be taking the sensor. I say like oxygen sensor, pH sensor, the oxidation sensor. All will be taking the quality of water, and then after analyzing those data, after analyzing, storing those information, we can actuate now those hardware we use. The main one will be just a valve. Yeah. For the next one, here for the next comprehensive documentation, the system architecture. There we go. A centralized control center with the operator's workstation, a SCADA server, and compatibilities for storage, data storage and analysis are described in this photo page. Yeah, we're having the fuel treatment installation, employ remote terminal to interact with actuator and sensors and communicate with the SCADA. Yeah, we'll be having our fuel contain our water ready to to be analyzed. Yeah. Then we are going to install those sensors, which will be taking the quality of water, and the process will follow as seen. Data collection. For the data collection, we'll be collecting the data from the tank, from the plant, water plant, and analyze it. The control center RTU can communicate with each other more easily thanks to the radio frequency infrastructure. Yeah, I think the radio frequency are the most used when talking about the communication. And this one, and this part here, it will be helping us. Yeah, it will be helping us to link our central control and our plant. Yeah. Hardware specification: the ability to interface with sensors that measure temperature, humidity, water level, air quality, pH, oxidation, reduction potential, stability, dissolved oxygen and energy uses in requirements for RTU. Mean what? Those sensors will be after collecting the info, after collecting data, it will send it to the RTU, so RTU also can send it to the central control center. Yeah. The selection of sensors and the few treatments process in contingent upon environment condition. Yeah. The whole process of treatment or water treatment will follow according to the environmental condition. So it can't be usable for the environment. The SCADA configuration, yeah. The SCADA configuration, we have in our software, which will be configured to collect data from RTU. Mean sensor will send data to RTU. RTU also will send to this control center. To the control center will be having the software, SCADA software, to monitor all information. Yeah, which will be provided by the HMI human machine interface for operators and generates alarm trend and reports if there is any change to the plant. The control logic is implemented to enable remote control action through the SCADA HMI. Meaning what? Every decision which will follow, every alarm, everything which you can be taking, like the process of troubleshooting the plant if it's crashing, for example, it will be showing, those information will be displayed to the SCADA HMI. Yeah. Then about the communication protocol, the system it will use the Modbus protocol for communication between RTU and the SCADA server. Yeah. Data transmission between the control center and RTU is facilitated via radio frequency. As I said, in communication, the most signal used is radio frequency. Deployment plant. The deployment strategy describes how to build up communication infrastructure, configure SCADA software, and install RTU fuel treatment facilities. It consists of operator training session and testing protocol to guarantee correct operation. As in IT, once you are developing a project or a prototype, you have to test it so that it can be acceptable to the environment. It can't be a danger to the environment. So here we are going to test. It consists of testing our system and verify those protocols so to guarantee a correct operation. So once we are treating the water, we'll be almost 100% sure of the quality of water we are providing. This is the last point of our session. We're talking about the reference. Those are references which help us to make up this one. So about the assignment, it will be very big. It will help you to, once you are following step by step, you will understand how with SCADA software will come up for the configuration. Yeah, for the configuration and remotely control a plant. Yeah. Thank you, and this is the end of our session.